All right, today class we're going to go over our objective. I will understand what prime factorization is and how to show it with Cuisenaire rods and factor trees. All right, so we've learned earlier in our lessons that we can show, using the number 6, we can look at our Cuisenaire rods and we can find out what the factors are of that by saying what times what equals 6, okay? So we know from past experience that you can either get 3 sets of 2 or 2 sets of 3. Okay, let's go ahead and show that with our Cuisenaire rods. All right. So we've got the number 6 here. Okay. So we know, like I said earlier, that we can either do 2 3 rods or we can do 3 2 rods. Either way, it equals the same thing. All right. So we've learned that 2 and 3 are the factors of 6 because 2 times 3 equals 6. All right. So what we also can do is we can look at this, and what I've drawn here is 2 lines to show that this is a factor tree. Okay. Other than 1 and their number, they can't be broken down anymore. The only thing you can do with 2 is put 2 1s out, okay? The only thing you can do with 3 is to put 3 1s out. So that means that 2 and 3 are prime, okay? All right, 6 is what's known as a composite number, which means it can still be broken down into other factors that are not 1 and itself, okay? So let's try something a little bit harder, and we're still going to use our Cuisenaire rods to help us. Alright, let's try the number 24, okay? Obviously, we don't have a 24 Cuisenaire rod, okay? But we have an 8. We know that 8 times 3 equals 24, okay? So I'm going to write 8 and 3. Alright, let's see here. But let's see if I'm right. Alright, so we've got 8 times 3, okay? Alright, so that equals 24. Alright. So we know that 3, like we said earlier when we were doing the prime factorization of 6, that 3 is a prime number, so we can't break that down anymore. So he's just going to stay there and hang out. Okay, but we have 8 to deal with, so let's just use 1 8. Okay. So let's see. We know. Let's try this. Let's try 4s. All right. So we can see that 2 sets of 4 also equals 8. So we're just going to give it another tree. We're going to go 2 and 4. All right, so we already know that 3 is a prime factor, so we're going to leave him alone. And we now know that 2 is a prime factor as well, so we're going to leave him alone too. He's just going to chill out, but we have to deal with 4, okay? So we're going to look at 4 again. I'm going to grab some 2s here. All right, so we can see that 2 sets of 2 also equals 4. All right. All right. All right, now what we're going to do is we're going to write out the prime factorization of 24, its actual notation. So what you're going to do is you're just going to put 24 equals, and you're going to put these bottom parts of the tree in chronological order. So you're going to do 2 times 2 times 2 times 3. So the prime factorization of 24 is 2 times 2 times 2 times 3. All right, we've learned already that 2 and 3 are prime numbers. They cannot be broken down any more than just using 1 Cuisenaire rods now. So what we're going to do is we're going to review a little bit. All right, so let's look at the number, let's say 10. Okay, and do one last one. So we know that our orange rod is our 10. Okay. All right, so we're going to do 2 sets of 5 because we know that works. All right, 2 and 5. All right, we learned earlier, obviously, 2, it's a prime number. What about 5? Can it be broken down any further? Nope. So what we're going to do is 2 equals 2 times 5. All right. Thank you, class.